So thank you very much, everyone, for coming. My name is Jeremy Allison. Jason Rodriguez I put down here as co-presenter, mostly because he's the engineer who's the lead engineer in charge of the FIPS project on top of Rocky Linux. He's very smart. He knows really what he's doing, and I shamelessly stole most of the slides from him. So, as they say, great artists steal. I'm not a security person by trade, unless you count introducing massive CVEs into some open source software, which I have personally done, unfortunately. I'm actually a storage engineer. My official title at CIQ is Distinguished Engineer. I'm one of the co-creators of Samba, the open source SMB file server project. So I'm basically a storage software guy at the protocol level. And when I joined CIQ, I was asked to help out with the FIPS effort. And so this talk really, although it would be much better if Jason was giving it, this talk is really about what is FIPS, why do you need it, what does it actually entail, and how would you get FIPS certification, or if that's what you really need when you're building a storage product. And of course, if you've actually been through FIPS certification, you can probably run screaming from the room right now. Okay, so what is FIPS? If you haven't run across it before, you're not in the US. FIPS stands for the Federal Information Processing Standard. And it's a set of standards that are administered by NIST, the National Institute of Standards and Technology, and it's designed for non-military government computers and contractors. It's very widely adopted and used, so it's not just used by the government. A lot of corporations also would like FIPS certified software. So right now, the official standard was FIPS 140-2, and that has been sunsetted. They're no longer accepting new submissions for the FIPS 140-2 standard. The new standard that we're working on right now for Rocky Linux is FIPS 140-3. And essentially, all of the FIPS 140-2 certifications have gone on the historical list, and essentially 140-3 is tightening of restrictions. As computers get faster, algorithms get broken, they become considered insecure. You need to keep moving the standard forward in order to keep a secure computer system. And what we know about how to create secure computer systems obviously keeps advancing. And mostly it's removing algorithms and increasing key sizes, basically, if you're into crypto. So NIST actually regulates FIPS. They have two programs. There's the Cryptographic Algorithm Validation Program, which basically says which algorithms do we accept, why, what key sizes, why are they good enough for government information processing. And then there is a cryptographic module validation program, which says, okay, so you've implemented these algorithms. Did you do it right? How can we know that you did it right? How can we test this? How do you prove that what you implemented follows the standard? And so on and so on. Now, I'm a software storage guy, not a crypto engineer. So one of the things that you will find, if you are like me, a software storage guy, when you go into FIPS for the first time and you look at the standards is, what does that mean? You look at many of much of the text in those standards, and I'm just sat there scratching my head, because they're written for cryptographers, they're not written for programmers. And so, the public key function shall mandate the P and Q. I'm looking at this thinking, last time I did math like this was 40 years ago in college. I've forgotten all of it. What does this mean? So it's very helpful to have someone on staff like Jason, who understands a lot of the actual meaning behind the regulations and the restrictions in those standards documents that can help mere mortals who have to program the thing be guided through it. And hopefully, and mostly, you're not writing your own cryptography. You are validating existing implementations. Now, I'll go into that and exactly how that works in a little bit. So, the algorithm validation program. Obviously, they've decided which algorithms meet the standards, and you have to inject known inputs. So these are called known answer tests. You have, here's a blob of data. When it's been processed by this algorithm in this particular mode, it comes out with this other blob of data. And you have to, on startup, the software has to prove that the known answers will produce the known outputs. And that's showing that your algorithm implementations are functioning correctly. And you have to prove that to a lab that is contracted by NIST. You have to pay for this, of course, as the vendor. And they will issue a certificate that shows that the algorithms you're using are compliant on a specific operating environment. And what does that mean? I'm going to go into that in a little more detail. And the other thing to note is, if you change the operating environment, you're no longer certified. Well, what does that mean? Okay. So here's an example. These are the ones that we are working on. So if anyone isn't familiar, Rocky Linux is essentially the successor for CentOS Linux. It's run by a non-profit, the Rocky Enterprise Software Foundation. CIQ, we're a company that provides support for Rocky, but we don't own it. It's not a CIQ product. It's, Rocky itself is an open source project. So we're showing an operating environment running on Rocky 8 instance, for instance, but you are specifying the exact processor and the exact processor type. And not only that, it can come down to what kind of motherboard you're using. Essentially, you are specifying the hardware right down to the BIOS settings that you're using on this particular machine. If you change that, you're no longer certified. So what does that mean for customers? I mean, so here are the algorithms, typical algorithm tests that are being done. Mostly AES, obviously, with different key lengths, etc. So the module validation program, this is the piece that actually tests the implementations. Essentially, you have power on self-tests, and this can be thought of as equivalent to the power on self-tests that a computer undergoes when you're first turning it on. It checks the hardware's working, it checks the processor's working, it can find all its devices, etc. The libraries that you use for crypto have to undergo essentially the same thing. They have to undergo what we refer to, I don't know whether it's widely used, as a power on self-test. So that means that when you load the library, before anyone can use it, you have to go through every single algorithm that the library implements that are compliant with FIPS standards, and you have to pass all the known answer tests. And then for any public key cryptography, you have to pass the pairwise consistency tests. That means every time you generate a public key, before you can hand that back to the caller of the library, you have to make sure that your public key generation and your public key validation is working correctly. So you have to do a public key check, a sign and verify check, encryption, decryption, and all these have to be done before. So you load a library, and all this is done in the library initialization function as the power on self-test. This is before the application can start using it. And every time the library is loaded, this has to be done on every instantiation of the library. So it's slower than regular because you can't just load the library and start using it. And then the final thing, and I as a software engineer, I find this a little strange, especially because it's software, but you actually have to have a file on disk that contains a hash, usually a SHA-256 HMAC hash, of the library itself, of the literal binary stored on disk. Then you have to read that library, run it through. First of all, you have to check that your SHA-256 HMAC algorithm is working, so you pass the known answer test for that algorithm. Then you can read the library itself from within the library, and you have to hash it, SHA-256 HMAC hash it, and you check that the values match. Now, I found this a little odd, as I say, because I'm a software guy, and if I'm running the library and I've taken over the library, I can make it say yes. I don't necessarily have to perform that test, but those are the rules. Those are the things that we have to pass. Those are the things that we have to prove to the labs. And the other thing that you have to do is, and this is mostly cutting out code from libraries. This is mostly saying, no, when you're running in FIPS mode, you're not using these things. And if you try and use those, the library will return errors to the caller. So here's a piece that actually takes most of the engineering work. You have to do the lab validation, functional tests. So what you have to do is go through and annotate any library you're using, and you have to show, and I've spent a lot of time on this. Essentially, you put print statements in, you go by syslog, or I run this through setting environment variables. You actually have to say, yes, this test ran successfully with this key size, with this algorithm, doing encrypt, using decrypt, using sign, using verify, etc., etc. But to prove that because of course, you could just put a bunch of print statements in saying, oh yeah, sure, this worked, without actually checking anything. So what they want you to do also is they want you to put in code that will deliberately corrupt the algorithms that you're testing. So the way I do that is you'll load in a known answer, and I just flip one bit. I XOR one bit in the incoming data, and I show that it doesn't match the known answer test. And with that, again, you have to, I've basically set it up for the library I've spent most of my time on, which is GNU TLS. You can essentially, before you run any GNU TLS application, you can set an environment variable that says, hey, I'm going to dump out all this data, and then B, I want you to corrupt the AES-256 encrypt test, or the AES-256 decrypt test. And it will then deliberately fail on the particular thing you asked it to fail on. Now, this code, very time intensive. You've got to run a lot of scripts to make sure it works. I have tests for the kernel. I have tests for lots of libraries. Very few vendors publish this code. In fact, even for an open source project, because this isn't code that is shipped to the public. So even if it's GPL licensed, because you're only shipping this code to the labs to prove that you made it work, or that you can corrupt it on demand. You're not shipping it to a customer. You have to show the lab the code, but you don't have to ship it to customers. And so right now, to our knowledge, OpenSSL is the only open source software project that ships these tests and shows how these tests are done. All the other libraries and the kernel that you have to test, none of that stuff, none of the other vendors who've got FIPS certification, some of the quite large ones, have, to my knowledge, have ever shipped this code. Well, CIQ of our Rocky Linux, we're planning to change that. We're going to publish everything. We're going to publish every single test, all of the functional tests. I'm going to put that on a repo hosted by the Rocky Enterprise Software Foundation. We're still working out the details of that. Then you have the hideous source code review forms, which are sort of like 100, for each module, it's like a library or kernel or whatever, you have a 100-page document, and they want you to go through every single algorithm, where it is, what variables were changed. It's a slow process. And then you have to have a security policy document that says, here are all the approved modes of operation, here are the things that we will allow, here are the things we won't allow. As you can see, this is quite a task. And so this is why few open source projects themselves will do this, and they depend on commercial vendors. Red Hat do this, Oracle have done this, obviously IBM, Microsoft have this for Windows, Canonical has it for Ubuntu. I don't think Debian has it because they're a volunteer project. So it's mostly vendors who will fund this work. So here are the FIPS packages we're planning to publish. We're doing FIPS 140-3 for both Rocky 8.6 and Rocky 9. Rocky 9 is somewhat easier because that work has already been done because Rocky is a rebuild of Red Hat Enterprise Linux, so a lot of that work's already been done. It's not been done for 8.6. 8.6 had FIPS 140-2, but not 140-3, so that's where most of the work has been going on. A lot of the stuff has to be backported into the earlier versions of the libraries in Rocky 8.6. The kernel has been interesting, so I spent most of my time on GNU TLS and the kernel, making things work, or rather, fail in the right way. So here's something that I really didn't understand before I went into this process. What's the difference between FIPS certified and FIPS compliant? A lot of people will use them interchangeably, but they're not the same thing. Now, FIPS certified, a FIPS certified product has gone through all of this process, all of this laborious, time-consuming process, all the code changes, etc., and has been certified by a NIST-approved laboratory, and they've basically given you the certificate that says, yes, this is a FIPS 140-3 approved product. Change the motherboard, change the BIOS, oops, you're no longer certified. So the one that I found really amusing was it literally if you turn on or off the AES NEI instructions, which is the Intel accelerated AES instruction set, which can be turned off in the BIOS, you can flip from being certified to not certified just by making that one BIOS change. Now, for some customers, usually in the government, they literally require FIPS certification. So it's like, look, tell us what your FIPS certification says. Here's the motherboard, here's the list, here's the disks, here's everything. We're just going to buy that machine. And we'll run it on that, and that way we know we are FIPS certified. This is my opinion, that's rare. Most customers just want to know, hey, I'm running the same code that the government guys are running, right? They don't necessarily want to say, oh, I'm running on the same motherboard with the same processor or whatever. They want the best deal, they want the cheapest hardware. So what most customers actually want is FIPS compliant code. In other words, this is code that has gone through the certification process. Please correct me if I'm wrong on this, by the way, for people who've been through this process. But my understanding is most customers want FIPS compliant code, not necessarily certified code. Because for certification, they're going to have to run it on exactly the same hardware, etc. Yes, comment. Someone's going to tell me I'm an idiot. Thank you.
No, I'm not going to do that. I'm going to tell you as a former Fed, FIPS compliant has no meaning. You are either certified or not certified.
Oh, yes. No,
so a customer, if I were a customer asking for FIPS compliant, I've asked for nothing.
Yes.
So
yes.
You can't even equate them. So anybody who basically is asking or accepting that, if you're a vendor, you try not to snicker as you walk away and say, we got your back.
So the comment was, FIPS compliant has no meaning because you either have the certificate or you don't. And that's true. I'm sure that's true. But the number of people who actually require that certificate, FIPS certification, is, I don't think there are that many of them. I'm sorry?
There are more people who require it than those who need it. Some people
Okay.
ask about it because
Right.
they need it.
So the comment is there are more customers who think they require it than actually do need it.
Yeah.
And that's probably true too. But as I said, essentially it's like a token that you have to have in order to play. Once you've gone through FIPS certification, the customer says, well, okay, I know that you can do FIPS certification. So if I'm running the same code, then kind of, I know it's good. Oh, there's a question at the back. Sorry.
Where's the hand? Oh, there.
I mean, if it's just a bit in your BIOS flash memory that can disable your FIPS certification, how do you, as a vendor, prove that you never do this?
I'm sorry that...
How, as a vendor of a machine combination together with operating system, prove that you will never ever flip that bit?
So the question is, if just flipping a bit on the BIOS will break your certification, how can you prove that? Well, that's not my problem. I've sold you a FIPS compliant operating system, FIPS certified operating system. If you run it on FIPS certified hardware, if you mess with the hardware or the hardware dies, I didn't do that. You did that, or the server did that. Yeah, you know what the settings are, don't change them. If you do, that's your fault.
So it is my understanding that for module compliance, you actually have to have a bit that says whether or not you are operating in FIPS mode. And the other thing that I remember for what it's worth is that FIPS compliant was verboten language.
Okay, so the comment is each module, a library or kernel component, has to have a bit that says it's operating in FIPS mode. That's true. I'm going to go into that in a little bit. Usually it's a command line parameter on the kernel or an environment variable or something that tells the library that you can query you're in FIPS mode. The comment about FIPS compliant being verboten, I'm not a sales guy. You may very well be completely right. I'm just an engineer, and I'm thinking about what customers actually do with the stuff that we give them. So I'm going to defer to your superior knowledge on that.
Well,
Yes.
I don't think it's verboten. I've seen it all over the place. So, I mean, if there's a law against it, there's a lot of people that are breaking that law. But actually, the right terminology is not even certified, it's validated. Is it FIPS validated? And the agencies you're referring to are FIPS validation agencies, not FIPS certification agencies. So I have a chart that looks just like that that says you want FIPS validated versus FIPS certified or FIPS compliant.
Okay, so the comment is I'm using the wrong terms completely, and it should be FIPS validated. And you know what? As you may be able to see, this is, let's see, that's one of my slides, not Jason's. So I'm going to take the hit for that. As I said, any mistakes in this talk you can ascribe to me, because I'm an engineer who's helping out the effort. I'm not going to blame Jason for any of my mistakes. So yes, another comment.
I don't know how relevant this question is, but from a SSD vendor standpoint, we're being asked more to have FIPS SSDs. This is more software, right?
Oh yeah, this is,
system,
sorry,
but-
if you're a hardware guy, I got nothing for you.
Yeah,
I'm
so
sorry.
in that situation where the software has FIPS components in it, like an SSD that's saying I'm FIPS compatible, again, how do you assure that you're using FIPS, hardware and someone hasn't changed or moved that, or it's not FIPS compliant? You have to have certification for the hardware components as well, surely.
I believe that's what the operating, the comment is you have to have certification including the hardware. That's basically what the operating environment defines, I believe. I'm not a hardware guy, so I'm sorry. This is mostly a talk about, hey, you want to do FIPS compliance, you're using open source software, here's how we're doing it. So for actually the code on an SSD, maybe if you got the FIPS OpenSSL version and you went through the compliance or verification, process yourself, then you would be able to get that verification certificate. So
the question I think you ask is a little different than that. I mean, so if you're talking about like a FIPS SSD, for example, right? it's validated, and you're putting it in like a server. FIPS 140 covers just the cryptographic modules. It doesn't cover the security of the SSD or the server. So from an SSD perspective, like an Opal drive, it's a subset that you're really actually going through a certification program. You want more than that, you got to go to common criteria. You don't have a FIPS certified server, or a validated server. It's always about the module. I also had, and it's somewhat related because you triggered it.
Oops.
You mentioned FIPS 140-2 and FIPS 140-3 and the importance of this. And I think it's important for the room to understand that as we stand today, you can't do 140-2.
Yes.
A total of 9 products have been validated under 140-3 since its inception. None of those are hardware, and there are approximately 400 sitting in the queue. Big windup.
Yep.
How are you dealing with that?
We're sitting in the queue.
Okay.
Sorry. So the comment was, yeah. Oh, okay. A long queue. Anyway, we're in the queue. Yes.
And how are your customers dealing with your being in the queue?
Well, the customers basically are saying, when are you going to be done? As most customers do. Anyway, so this is one of my slides, my personal opinion. So going back to algorithms, what are unapproved? And this is where it gets interesting, at least as a software guy. Here's a partial list of algorithms that are now unapproved. You cannot use them. Having said that, the standards say that you can use them so long as they're not being used for verification or security reasons. And I'm going to go into this a little bit more. Essentially, my understanding of this is that, and there are some protocols I'm going to talk about in a little bit. Essentially, you can tunnel those inside an approved algorithm. So if you're using a very bad, let's say you're using RC4, whatever, that's not approved in any of the modules. If you had your own implementation and it was tunneled inside an AES or a TLS 1.3 protocol tunnel, then essentially FIPS says nothing about that. It's like, okay, you're not using it for the main security of the protocol itself, so therefore we have nothing to say about using such horrible, crappy algorithms anymore. And again, as I say, it's pushing the key sizes higher and removing algorithms that are considered broken. So going back to storage protocols, some of the storage protocols, updating storage protocols is hard, and they haven't kept up with FIPS and the algorithms moving forward. So obviously the classic one is NTLM. iSCSI is another one. With iSCSI, authentication depends on challenge, authentication protocol. Can't remember the acronym for that. But that only requires MD5, which is not an approved algorithm. Now, having said that, if you look in the Linux kernel, the iSCSI initiator can use FIPS-approved SHA-256, but we have a problem with a cloud vendor who has bought a bunch of iSCSI targets that will only speak MD5. Like, well, how do we get a FIPS authentication? How do we get a FIPS compliant certified environment through that? Yes. SMB3, which is obviously the protocol I know most about, that can be run in a FIPS approved mode. Obviously, SMB1 cannot or should not. Again, NFS v3 and 4 you can run in FIPS approved mode, but some of the DC RPC Microsoft pipes have old crypto embedded in them. So some of the LSA protocols mandate RC4. Again, you have to wrap these in more secure algorithms to be able to use them. It's kind of interesting, as I say, I know most about SMB. Essentially, if you're not using Kerberos, hardened Kerberos and Active Directory, you're not going to be playing in the FIPS world for SMB3. Sorry, and as Jim says, even if you are, you're probably tunneling it. Okay, so I'm still using horrible terminology here, but as I said, this is my slide, not Jason's. So if you want FIPS certified, FIPS validated, you're going to have to go through all of these processes yourself, validate your modules, validate your libraries, get a certificate, get a ticket from the labs, and get in the queue, essentially. So what I'm talking about is building a product that's based on code that has been certified. So whether that means anything to the customers, who can say? I'm not a sales guy, as I said. So I would start with a FIPS certified Linux. Windows has also been FIPS certified, but I'm an open source guy, so I'm not gonna. If you want Windows, you know where to go. The thing to do is you must not use your own algorithms. You must only use the modules that have been certified. So that means you have to use the OpenSSL, GNU TLS, any of those. You can't do your own crypto, essentially. They require the power and self-testing, so that everything's going to be a little slower. Everything has to be run on a library load, and any other algorithm outside of that is disallowed. So here's someone who made a comment about there has to be a bit that says you're in FIPS certified mode. So at least on Linux, there's a handy command called FIPS mode setup -- enable. And when you run that, it turns the whole system into FIPS mode. It will put a boot parameter on the kernel command line. It will rebuild your init RAM-FS. And next time you boot up, you're in FIPS certified mode. You can actually then ask proc sys crypto. You can pull out of the kernel, say, hey, am I in FIPS mode? And it will tell you yes. And the libraries use that to say, I'm in FIPS mode, therefore I'm going to shut down these algorithms. I'm only going to do these things. If you are using all the standard libraries, you're not using any of your own code, then everything will work. If you are using algorithms that are not FIPS approved, your code will start to break. And I'm pointing out this because this is, again, obviously the code I know most about, is Samba itself. Versions before 4.12, we had our own hand-built crypto. So this is never going to be FIPS compliant. No one is ever FIPS certified. No one is ever going to go through and do this for Samba. Later versions, we've switched over to using GNU TLS, which has been FIPS certified. So because of that, if you are doing any crypto in your storage product, and I would say these days 100% of products use open source code in some way, shape, or form inside them, you've got to audit it, and you've got to check that you are only using the approved modules and you're using them in the approved way. Because if you have handcrafted code that you're depending on and you're not using the approved modules, essentially you can never be FIPS compliant. You can never be FIPS certified, and you might not necessarily catch that. You have to harden Kerberos itself in an Active Directory environment to be FIPS compliant, FIPS certified. And the other thing I noticed is when you're testing all this stuff, and you've got to do a lot of testing, the helpful error messages you get out of the modules when things aren't working, they say things like, crypto system internal error. Oh, great. What does that mean? And you look for that, there's a million different places that could be. And what that will actually mean, I think this comes from OpenSSL, that means is, hey, dummy, you use an algorithm we don't approve. It doesn't say that. It says, crypto system internal error. Great, thank you. So you're going to be doing a lot of work. So what if you have to use unapproved algorithms, protocol requirements, etc., or customer requirements, where they say, well, we want the FIPS code, but we're actually going to cheat and not use it that way, which happens, as I've mentioned. So you can actually deliberately put the libraries into a non-approved mode. You can say, the one I'm most familiar with is GNU-TLS. You can say GNU-TLS set lax mode. In other words, hey, the next thing I'm going to do is not going to be FIPS compliant. Then you do the unapproved thing, then you go back. So other libraries like OpenSSL, once you're in FIPS mode, there's no getting out of it. So for one customer, we actually had to build a specific, on the FIPS system, we had to build a specific private version of some open source code that wasn't in FIPS mode that they could link against statically so that no other library on the system would use it. Basically, I'm telling you all the ways to cheat to make a product actually work. This is probably not what FIPS people want to hear, but this is what has to be done sometimes. And of course, NTLM is the worst offender, at least for SMB, because NTLM is not and will never be FIPS approved, but of course, almost everybody in the world who's using SMB has some NTLM somewhere in their environment, usually because their DNS is broken, and so Kerberos doesn't work right. So, yes, comment.
What's NTLM?
Oh, sorry. NTLM stands for NT-LAN Manager encryption, and it's based on the original Windows password hash is an MD4 hash of the user's password, and then it's basically a hand-created Microsoft authentication mechanism. And it's the thing that is mostly used for standalone servers and clients. When you don't have Active Directory set up, you don't have a large Kerberized environment, and mostly when you connect to a server and you don't have its DNS name, you only have the IP address, Windows will fall back to using NTLM as the authentication. It won't get a Kerberos ticket because it doesn't know how to get a Kerberos ticket for the target machine. Does that answer the question?
So that's an instance of anybody can invent encryption that they cannot break.
So the comment was Microsoft invented encryption that they couldn't break, so it's secure. This was a different time. It's easy to throw rocks at Microsoft here, but there are many vendors who have done similar things in the past. This was a time before widespread Kerberos, before widespread security policies, and so that was kind of like, well, we need a secure way of doing password. It's better than NFS, which had basically, trust me, I'm giving you the user ID. Trust that's who I am.
Okay,
so
I didn't mean to.
I know that a lot of Microsoft people here, and don't get me wrong, I've given Microsoft a good kicking on many occasions, but I can't really blame them for this one. And NTLM works in cases where Kerberos, where DNS is broken, which is most of the time where Kerberos does not. So let's see. So Linux kernel, once you turn the system into FIPS mode, Linux kernel turns itself into FIPS mode by having a FIPS equals 1 command line parameter. And at that point, the kernel changes and it will make sure that only FIPS compliant algorithms are available. And even through the crypto API, once the kernel is in FIPS mode, if you ask for a non-approved algorithm, it will not allow you to use it. It's kind of, the kernel is kind of interesting because internally all those algorithms are still there. So inside the kernel for certain things, there are non-FIPS approved algorithms that are still used, but they're not able to be accessed outside of the kernel. So, couldn't read that, but I think I got 5 minutes. Obviously, in order to make this make any sense at all, you have to have secure boot set up so that you can't change the command lines to the kernel and put it out of FIPS mode in that way. It's kind of interesting. The kernel was the piece that gave us probably the most trouble making the 8.6 kernel, which I think is a 4.18 kernel, work with FIPS 140-3. So, talking about this, I was going to be really mean about the kernel crypto subsystem because this is the kind of code, and this is in upstream Linux, right? This is the kind of code that you have to deal with, and you know, I would, yeah, exactly. This is look how clever I am code. This is not code that is meant to communicate intent. That's in the upstream kernel. I had to figure out what that meant, put something similar down in the downstream in the older Rocky 8 kernel. I don't blame the person who wrote that. I was going to be very mean about the maintainer who allowed that code to go in. Having said that, there's been a very recent thread on the kernel mailing list about how maintainers are overburdened, overworked, not paid, etc. So I'm not going to say anything nasty about the maintainer who put that in, other than they must have been having a bad day when that code went in. And so here's, yeah. So just from an engineering perspective, unless you have a lot of really, really good kernel engineers who know their way around the crypto subsystem, you're going to have to budget a lot of engineering time to be able to make sense of this stuff and to make it work. And, you know, he's not here, so I'm not going to embarrass him. But I do want to show the kind of code that I'm used to seeing. So here is a commit message from Samba. Recently, oh, his name's up there, never mind. So this was a commit that went in recently to fix a race condition in Samba. And look at the difference. So here's basically here's a novel describing what the code is, what the error code you got was, you know, because this is really, really subtle stuff, right? And then, you know, even when you get down to the code change, again, here's a novel explaining the race condition, how it happens, why we have to do this. You know, otherwise, in the Linux kernel, that would be if server ID equal blah, go to watch again. And you would be left thinking, but why? Anyway, I just wanted to show the difference between...
and it's only 4 lines of code.
Yeah, exactly. I just want to show the difference between what I consider to be well-written code. Oops. Oh, no, it's gone back to there. Okay, sorry about that. What I consider to be well-written code and code that probably should have been requested to be rewritten before it went in. Okay, I'm running out of time. So if you're going down the FIPS route, is this going to make support worse? Oh, yes. Once you turn on FIPS, you get certification, verification, whatever you want to call it. Your support staff are going to have a horrible time. Everything's going to break. Things that people were previously doing are no longer going to work. They're not going to know why. They're going to get helpful messages like crypto subsystem error. You know, so this is going to be a painful thing. So what you've got to do is test all the support critical components to make sure that they can access systems that are set in FIPS mode. You're going to have to do a lot of training on your customer support people to actually understand and see common interoperability problems that are going to happen when some systems are in FIPS mode and some systems are not. And, you know, let's be honest, FIPS really only likes talking to FIPS. Once you've got FIPS systems, they're happy talking to each other, theoretically. So, you know, biting the FIPS bullet is something that you really have to adopt wholeheartedly as an organization rather than just having some part of it. And remember, 140-3 is more restrictive than 140-2. So anyway, that's mostly it. Oh, I think, let's see. All right, yes. Of course, the one thing I missed and I really should have gone into earlier, and please, again, this is one of my slides, so forgive terminology errors. Any change to your operating environment will remove your certification. But what happens if a severity 10 CVE, like the kernel SMBD error comes out? I've got a FIPS system, I want to patch it. Well, you can't. If you patch it, you're no longer certified, you've lost that certification, you would have to go through and recertify. Take a ticket, get in the queue. So it's interesting. Software's developed so quickly, it is FIPS, I believe, and this again is just my feeling, was developed for an older, slower moving world of proprietary software. In the modern world, everything's got open source software. You get 10 CVEs a week coming in. You've got to decide which ones are important, which ones you're going to patch. It's hard to deal with that speed in a world where it takes 2 months or 10 months to get recertified. I believe that there is a revalidation process that allows changes to be reevaluated quicker than getting a full recertification. But if you patch any of the modules or the kernel, even for a severe CV fix, it means you are no longer FIPS certified. So it means essentially people have to choose between maintaining FIPS certification, verification, and being secure, which I don't think is a great choice to have to make. Now, I'm not 100% sure about this, but I believe that CV fixes in the other components do not affect. So if you're not patching the modules, they do not affect FIPS compliance. If someone knows better than me about that, yes.
In the 140-2
Okay.
in the 140-2 days at least, there was a much faster process if you did not touch any of the cryptographic firmware.
Okay.
And I assume that's still the case?
We don't know.
Right?
Hopefully we shall find out. But yes, so if you are not patching any of the crypto modules or the kernel, then hopefully that will be a quicker way to get patches for
And less
say,
expensive
CVs.
than what you pay the lab.
Yes. But again, it's not customers who pay the lab, it's vendors who pay the lab. So, remember, the number of CV patches that come out in a week is very large. So what this generally means is that you tend to freeze an environment and you only patch when you really have to, because it's, a massive disruption to your existing systems. Yeah, comment from Volker at the back. Question, sorry.
Just one simple question. If I would normally buy a server for, say, 20K, how much does it cost if I add the FIPS label on it?
So that's an interesting question. So long as you're buying the server that the code was certified on, it shouldn't cost you any more than, remember, if you're running Rocky Linux, hey, it's a free download. Once it's FIPS certified, then you can run that on the same server, and it's not going to cost you any more. Remember, the customer is not going to get the certification. The vendor gets the certification for that operating environment. So
for example, Dell as a server vendor would take your free offering or whatever, get your certified RHEL clone,
sure, yeah.
and then go to the officials and say, okay, this combination is to be certified, and I talk to Dell then.
Well,
because
you would buy
I,
that.
as an end customer, would buy a FIPS certified whatever hardware, download a free operating system where somebody claims, hey, this is FIPS certified.
Well, not
this
claims.
can't be true.
You can download the certification that says this on this hardware is certified. Yes, great, go ahead.
Okay.
If you want support, open your wallet, mister. So here's another question.
The little I've read about 140-3, you got level 1, 2, 3, and it really goes into the tamper-proof, gets more and more extreme as you go up there. Where does this fall in that spectrum going forward? Because it seems to me this is really easy to tamper with. Or have you got to have, I assume the whole aspect of 140-3 is you get level 1, 2, or 3. You go to 3, you then will have to show you can't tamper with the thing, right? So I'm just kind of curious where this all fits.
I can answer that.
Yeah.
Thank you, because I have absolutely no clue. I was
historically,
Jason.
historically, software could relatively easily achieve level 1. There were provisions for being able to get to level 2, which required a bit of magic. There weren't a whole lot of products or a whole lot of libraries that basically achieved that. It is not possible to go beyond level 2. So level 1 is probably what you're going to get if you see a FIPS label. Maybe like OpenSSL, I think pursued level 2, but there's not a whole lot of those that and under 140-3. I think it's all what we've seen, the 9 that have come out. I think they're all level 1, level 2.
So thanks for that, because I don't know would be my answer to the question. I would have to get back to you on that. So I mean, to my understanding of it, how because software is so malleable, how would you really, unless you've got a completely secure boot environment from the boot process up with a TPM chip, etc.
Yeah.
There's no way to certify that.
Again, you're conflating all of the pieces. What's typically covered in a software evaluation is just the cryptographic modules. It's not all the pieces. It's not all the protocols. It's basically the library that the protocols would potentially be using. So as long as
I think it's a little more sophisticated than that, because at least for the kernel, the sources of entropy come into play. So you have to certify under specific sources of entropy.
Yeah, and entropy is always part of the validation process.
Yeah.
But so that's part of the cryptographic module.
Yeah.
So if you're doing that via software mechanisms, you're probably going to have some challenges because that.
Well, so the way the Lisa Linux kernel, the DRBG random number generator, depends on CPU jitter. Which is coming from the internal chip itself. I believe that is what most vendors have certified on. So you don't allow any other sources of randomness into it. You're just depending on the CPU jitter.
Again, I think if you look closely at the validation, because the hardware is going to change, and if you're dealing with just the software, they're just dealing with the library. So they're going to get it from some piece, and whether that piece is acceptable or not.
Yes,
because it can't be a system-oriented piece for the validation. So this is
there's a separate entropy validation that I know we're going through, which is based on and again, that's why the changing of the BIOS that change the CPU features, you have to freeze the CPU features that you're going to depend on. Because at least Intel has a RD-RAND instruction that is supposed to generate randomness that nobody trusts, from what I can tell. all of the things that I've seen everybody do is turn that off, and here's how you turn that off. And they've made it very hard to turn that off, by the way. But anyway, you turn that off and you depend on CPU jitter is what I was. But I'm a software guy, so this is, Anyway, hopefully this was helpful.
There was one question I don't think we answered earlier, and I don't remember who asked it, or maybe you said it. The roots of FIPS 140 is in hardware. So software got introduced very late in 140-2. It was not available in 140-1. So if you're wondering why software-based FIPS certification is so hard, because the underlying assumption in all the standards is it's hardware.
Right. Thanks for that. That's a helpful comment. Yeah. Right. Are there any other questions and comments? I think we're kind of running to the end of the time. So.
Just as a side observation for us, the last release that we have finished the validation for has been out. It was earlier this year, late last year maybe, that we passed. Was something that went out of service 2.5 years ago.
Oh, you mean the hardware?
No, the software.
Oh, yeah.
That it just takes that long to get through the whole queue.
Yeah. The customers.
And we didn't introduce changes in that time. It's just that it took that long to get through the queue.
The customers want to know that you're in the process.
Well, and that's where where the compliant language comes into play.
Yes.
It's a marketing thing.
Yes.
It's sort of, technically you're correct in that it's not a real thing, but that's why the discussions come in, because the actual validation takes forever. And by the time you get there, something's been found that's already broken somewhere else.
So you said actually some magic words that are good. Under validation. Those words are magical, especially with 140-3.
Yeah. All right. Well, thanks very much.
Thank you, sir.